Hey guys, let's go over the stats quiz number 10, basically all of chapter 3, taken February 25th, 2021. Question number 1. Evaluate the questions below and answer and select the statistical ones. Statistical questions. What makes a good statistical question? Well, it has something called variability. The numbers will vary. Okay, let's look at A. Do men live longer than women? It can happen in certain places, right? Different women live different amounts of time, and the same is true for men. So there is variability. So this is a statistical question, right? Maybe here in California, men and women both live to 80. And maybe in Nevada, it's men 78, women 76. It can vary in different states. That's the point. Okay, here's another one. B, how long do people live? There are many people in the world, and they live at different lengths of time. So maybe in Africa they live to 70, and maybe in Cuba it's 40. So how long do people live is a statistical question. You're going to get varying different ages and numbers. Okay? But for C, how long did Abraham Lincoln live? It's a specific person. It is known how long he lived, and there isn't real. It's just one straight answer, so there isn't any variability in it. So this is not a statistical question. So the answers are A and B. Okay, question number 2. The athletic department at Hornell High School would like to determine the average height of the 1,200 male students at the school. Select from the following survey methods that would allow the department to draw valid conclusions about the average height of the male students at Hornell High School. Okay. I will give you a clue that it is select all that apply. So we kind of want to know what the average height of students are. If I measure the height of every student at Hornell High School and take an arithmetic average to determine the height, yeah, that's just taking an average. So that one works. B, measure the height of every student in the men's basketball team at Hornell High School and take that mean. So the basketball team, those guys are usually pretty tall, so no way. That doesn't give us a picture about all male students. C, measure the height of every student on the men's football team and men's volleyball teams at Hornell High School and take the arithmetic average. I think that's a good one, but again, those people on the sports team are generally taller. So that would be a no. Assign unique student IDs to all 1,200 male students at Hornell High School. Use a computer program to randomly select 120 male students at Hornell High School and measure their heights and take the arithmetic average. So that sounds like a simple random sample. And that would be, the answers are A and D. Okay, question number 3. Which one is an observational study? Remember, observational is where someone is just either just looking or they're kind of just having a clipboard here and they're taking notes. Okay? A company divides volunteers into 2 groups to test the popularity of a new version of a vitamin pill. Well, the company is kind of doing stuff, right? They're dividing them into 2 groups. So they're doing something. The researcher is doing something. That's not the point. Observational is just strictly just sitting there and watching. B, a researcher visits classes and records the time students are given to answer a question. So let's look at those verbs. Visits, kind of passive, just like a fly on the wall, just sitting there, and records. So they're not interacting with the students. They're not doing anything to the students. They're not giving them candy, anything like that. So B. A government agency sends questionnaires to owners of small businesses in 3 states. Okay, again, the idea is that the researcher shouldn't be doing anything, but they're actually being proactive there. They're actually sending out the surveys. So this would be no. And D, a company records the time it takes employees to park their car and enter the building. So again, this idea that they're just watching. So your answers are B and D. Question number 4. Determine whether it is an experiment. So in an experiment, you are doing something as the researcher. Okay, think of, I call it the claw, right? Back at Toy Story. A sample survey. So you're just getting some quick numbers. And then an observational study we did in the last one, you're basically just standing there and you are watching, okay? Let's look at this first one. In order to research the impact of sleep on the athletic performance, a researcher asked 50 subjects to sleep at least 8 hours. Okay, so I'm thinking in this one, they're doing something. They're taking 50 and they're saying sleep greater than or equal to 8 hours. And ask 50 other, so 50 and 50, so really 100. 50 here, sleep less than 6 hours. Okay, it sounds like they're doing something, right? This would be an experiment. A biologist studied 6 birds' nests and took notes on the qualities of each nest, such as the material height, nearby shrubs, and ecosystem. What was this biologist doing? It was studying, kind of just with their clipboard. So this one's going to be an observational study. In order to find the average weight of infants born during 1 year in a hospital, a nurse randomly selected 100 infants and reviewed their files for the weight information. Okay, so the nurses are doing something. Are they strictly just watching? In this one, they are actually doing a little bit more. They're being a little bit more proactive. It's not an experiment. You're not splitting up the infants into 2 groups. But the nurses are doing something. They're selecting them. They're reviewing their files. So this one is going to be a sample survey. Now you're not taking a weight of all of the babies. And that one is just a fancy word for sample mean. Okay, and the last one here. In order to study the impact of caffeine on blood pressure, a researcher assigned 50 subjects to drink 1 cup of coffee every morning, and 50 of the 50 subjects, 25 were given decaffeinated coffee without their knowledge. So they're basically given what? A placebo. So you didn't know it, but 25 of these had caffeine and 25 have decaffeinated. That is quite mean. But you're doing something, you're organizing them. So this is an experiment. All right, question number 5. Josephine owns a diner that is open every day for breakfast, lunch, and dinner. She offers a regular menu and a menu with daily specials for breakfast, lunch, and dinner. She wanted to estimate the percentage of her customers who order the specials. She selected a random sample of 50 customers who had lunch at her diner during a 3-month period. And she determined that 28% of these customers ordered from the menu with specials. So 28%, this is your proportion. You have 50 customers, n equals 50. She has an SRS, but I found that kind of interesting. She only asked who? Lunch people. Okay. Select the best statement from the choices below. The sample is the percentage of customers who ordered daily specials. That's partially true, but not the best one, because remember, the sample is actually a lunch sample. So it's not breakfast and it's not dinner. It's just the lunch people. So that's not the best statement. The sample might not be representative of the population because it only included lunch customers. Ooh, I like this one. Right? That's what I noted, lunch. Remember, the population would be breakfast, lunch, and dinner customers. C. The sample shows that 28% of Josephine's customers ordered daily specials. I would say that is generally true. But are you implying all customers do that? I'm going to write the word all. Because these are just the lunch people, right? What happened to the, how about the breakfast and dinner people? So, that's a pretty good statement, but not as good as B. And D, no generalizations can be made from the sample because the sample of 50 is too small. Remember, we don't know anything about how many people go to Josephine's diner, so yes, of course, a bigger sample size is better, but I think the best one would be B is our correct answer. Let's move on to question number 6. Two research groups conducted a poll asking city residents whether they were in favor of widening a certain road. The research group polled 310 people. Okay, so that's total. And 146 said yes. So yes divided by the total here. So you're going to have 146 out of 310. Which results from the second research group would be statistically significant. Okay, we talked about statistically significant before. We're saying that it's not due to chance. Not due to chance. Okay, so I'm going to highlight my answer in blue here. Because if you do that number, let's see, 146 divided by 310, okay? That number is 146 divided by 310 is 0.47, okay? Let's see if I can color code each of these. Okay, so 79 out of 150, this would be 0.526. Okay, not too bad, somewhere around here. This is the idea of like the simulation, the M&Ms, where you keep sampling a group of people, and is it close to what we started with, the 0.47? Okay, let's do another group. 140 divided by 225. This gives me 0.622. Okay, definitely a bit higher, definitely further away. Seems like not normal, right? Let me see, what color do we now have? Green. All right. 175, 382. Okay, this one gives me really close, 0.458. So somewhere around there. And the last one, 94 out of 185. 0.508. 0.5. There's the purple. Okay. Okay, so all of these are pretty close. Wouldn't you say? Okay, like color here. So going in the left direction, it seems like the deviating away from the center is not too far. It's like 0.12. Whoops. Sorry, trying to get a different color. Only 0.12 in that direction. Okay, now if you did 0.12 in the other direction, you would get something like 0.58, right? Add a margin of error. So that would include here and here. That means this one way over here, that one's pretty significant, statistically significant. So our answer for that one would be B. It's so far out there, it's not due to chance. All right, so that was our quiz number 10. See you guys